So this is the radical practice worksheet. So let's start working with some radicals or roots. So for number one, super simple, we have a simple radical with an x to the second power underneath. Now remember that simple radicals are power 2 radicals, which means that it will cancel out with the power 2 exponent. They are opposites, a power 2 radical, a power 2 exponent, so the answer is just x. For number 2, you have a 16 underneath a simple power radical. Well, 16 itself is a power 1 and the radical is power 2, so they can't cancel out. But can we write 16 as something else? We totally can. We can write 16 as 4 times 4, which is 4 to the second power. And again, since the radical is also to the second power, you can cancel the radical and the exponent, leaving you with just 4 as your answer for number 2. For number 3, you have 4x squared, or x to the second power. Again, a simple radical is a power 2 radical. So the x is fine, but the 4 isn't. But we can rewrite 4 as 2 times 2, which is 2 to the second power. And then you still have that x to the second power. And again, because a simple radical is a power 2 radical, you can now cancel everything underneath, leaving you with just 2x as your answer for number 3. For number 4, you have a power 3 radical, so now that we're going to write down the power, and y to the third power. This one's really simple. The radical and the exponent match, and so you can cancel them out, so that's just y is the answer. For number 5, you have a third power radical and an 8 underneath. Obviously, the 8 itself is power 1, but can we rewrite the 8 as something else? We totally can. The 8 can be written as 2 times 4, or it can also be written as 2 times 2 times 2, right? Because the 4 is a 2 times 2. So it's 2 times 2 times 2, which means you can rewrite it as 2 to the third power. And now this matches the radical, and now you can cancel them out, and the answer is just a 2. So that's 1 through 5. Pause this if you need to. I'll ask me any questions. And we're going to move on to number 6. For number 6, you have a power 3 radical with 27 m to the third underneath. The m is already good. It will cancel out, but the 27 won't, so we need to fix that. What can we do with 27? Well, 27 can be written as not lots of things, a few things. 3 times 9, and then 9 can be written as 3 times 3. So you can write it as 3 times 3 times 3, right? 3 threes. And then you still have that m to the third power, which means in its final form, it can be written as 3 to the third power and m to the third power, all underneath that power 3 radical. Now everything can cancel out because they're all, the radical and the exponent underneath match powers. So the answer is just 3m. So that is number 6. For number 7, you have a fourth power radical and a w to the fourth power underneath. This one's really simple. The powers match, cancel out, you're done. That's 7. Super simple. For number 8, you have, again, a powerful radical and a 16 underneath. This is sort of similar to number 2 over here, but in number 2, if you remember, we rewrote the 16 as 4 times 4. That's not going to work for number 8 because 4 times 4 is 4 to the second power. But can we rewrite 16? Like, okay, so this doesn't really work, right? Because that's 4 to the second power. But each of those 4s, can those be written as 2 times 2? Yes, they can. So instead of a 4 times 4, I can write it as 2 times 2 times 2 times 2, right? Which means now it's just 2 to the 4th power. And great news, they cancel each other out now. Boom, boom. So the answer is just 2 for number 8. For number 9, you have again a powerful radical. And here you have yourself 81 x to the 4th power. Again, the x to the fourth power is not a problem, but the 81 is. Now, 81 can be written as lots of things. Well, again, not lots, but a few things, and one of those is 9 times 9. That still doesn't work, but each of those 9s can be written as 3 times 3 times 3 times 3, right? 3 times 3 is 9, times 3 is 27, times 3 is 81. And this is where we're going to find our solution, because that is 3 to the fourth power, and the x is still there. And now everything can cancel with that power for a radical or a root, and you just have 3x as your answer for number 9. All right, that is 9. I'm going to move on to number 10 and probably 11. So let me know if you have any questions. Let's do it. So number 10, you have a simple radical with 9x to the fourth power. Now remember, simple radicals are power 2 radicals, and neither the 9 or the x to the fourth power match that. So let's fix it, if possible. So the 9, I can write it as 3 times 3. Now the x, I can split it into x to the second times x to the second. Why? Because x to the second times x to the second is just, you simply add the two exponents, right? Which is back to x to the fourth. I can split it however I like, numerically speaking. And this is the way I split it, because that gives me 3 to the second power, x to the second power times x to the second power. Essentially everything now underneath it is second power, which means now, and a simple radical itself is a second power radical, right? So even though we don't write that. So now everything can go ahead and match up with that, cancel out, and you just have 3 times x, which is 3x to the second power. And that is your answer for number 10. Just remember, these are both power 1s from the last lesson. And for number 11, you have yourself 16 y to the 6th and x to the 8th power. And let's see here. It's a simple radical over here. So I'm going to go ahead and see what I can do. The 16, I can write it as 4 times 4. And then the y, I can split it into y to the second, y to the second times y to the second. The x, I can split it again 4 ways. Again, I'm splitting the 8 into a bunch of 2's. And again, the 4 times 4, I just rewrite that to save some space. It's just simply 4 to the second power, right? And now, because it's a simple radical, I can cancel a bunch of things out. So what am I left with? 4 times y times y times y times x times x times x times x, which is just 4y to the third, x to the fourth power. And that is the answer to number 11. A little bit on the longer side, but, that is what it is. Let me know if you have any questions. Pause this if you need to. And let's move on to number 12. For 12, I have a power 3 radical, and underneath it I have 27, m to the 6th, y to the 9. So what can we do? Well, the 27, I can write it as 3 times 9, and the 9 is 3 times 3. So it's 3 times 3 times 3, or 3 to the third power. The m, I can split it into 2 3's, right? The 6 can be split into 2 3's, and the y to the 9, the 9 can be split into 3 3's. So now, because it's a power 3 radical, everything can cancel out, leaving me with just 3 times m times y times y times y, which is simply 3m to the second, y to the third. And that is the answer to number 12. For number 13, very similar story. You have 8x to the 12 and y to the 15. The 8 is 2 times 4, and the 4 is 2 times 2. So I can write it as 2 times 2 times 2, which is 2 to the third power. The x, the 12, I can split it into 4 3's, right? 3, 3, 3, and another 3. And the y to the 15, I can split that 15 into 5 3's, Oh my gosh. That's going to be annoying. So it's going to be y to the third times 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 y to the third, because, 3 5s is 15 and 3 4s is 12. Now everything can cancel. And remember, this is a power 3 radical. Everything can cancel with this power 3 radical. Boom, 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 because they're all the same power and they're opposites. So what are you left with? 2 times x times x times x times x times x times y times y times y times y times y, which is 2x to the 4y to the 5th power, and you are done. So that's how that works. It was a bit of an annoying problem, but I bet I got a few more annoying problems to go. So that's number 12 and 13. Let me know if you have any questions. If not, pause this if you need to, and let's move on to 14 and 15. All right, here the 16 can be written as 4 times 4, and each of those 4 is 2 times 2, right? So technically I can write the 16 as 2 times 2 times 2 times 2. We did this before, which means I can get it to be 2 to the 4th power. The m, I can split it into 2 4s, because I want to match everything to the radical, which is power 4. And the x, I can split into 3 4s. And now everything can cancel out with the power 4 radical. Boom, 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 which is perfect. So what am I left with? 2 times m times x times x times x, which is simply 2m to the 2nd power x to the 3rd power. And that is how you do 14. Just try to match everything to the radical if possible. For number 15, you have a power 5 radical, and underneath it you have 32, w10, b to the 15. The 32, I can write that as 2 times 16, and the 16 is 2 times 8, and the 8 is 2 times 4, and the 4 is 2 times 2. So I have 1, 2, 3, 4, 5. I have 5 2's that make up the 32. So it's 2 to the 5th power, or 2 times 2 times 2 times 2 times 2. So I can write that as 2 to the 5th power. The w to the 10, I can split into 2w to the 5's, right? The 10 can just be split into 2 5's. And the b can be, the 15 can be split into 3 5's. Oops. 5, 5, 5. Boom, right there. And now everything can cancel with this power 5 radical. So boom, 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 boom. What am I left with? 2 times w times w times b times b times b, which is just simply 2 w to the 2nd power, b to the 3rd power. And that is the answer to number 15. All right, let me know if you have any questions. Pause that if you need to. And we're going to move on to the last 4 problems. Number 16 coming up. All right, for 16, it's a little different. Here you have an equation. And again, we're trying to solve for x. I want to get x all alone, which means I need to get rid of this power 2. What is the opposite of exponents and powers? Well, as I told you at the start of the lesson, it's radicals. And what is the opposite of a power 2 exponent? It's a power 2 radical, which is simply a basic radical. Because remember, basic radicals are already power 2 to begin with, right? So I'm going to apply that to get rid of that exponent. But whatever I do to one side, I got to do to the other side as well. Well, on the left side, that's gone, and that's exactly what I want. Now I just have the right side to deal with. But we've done this. We already did 15 problems just like this. So this should be pretty easy. So all I need to do is get the 4 to be a power 2, which is not a problem. I can make it 2 times 2, which is 2 to the 2nd power. And the y, I can split that 4 into 2 2's. And now again, because a simple radical is a power 2 radical, everything gets canceled out. And x is simply 2 times y, which is 2y to the 2nd power. So that is number 16. That's how you would solve that. 17 is very similar. You have x squared equals to 9m to the 6th. Same thing. I want to get rid of that power 2 exponent, and the opposite to that is a simple radical, which again is a power 2 radical. Simple radicals are power 2. You don't have to write the power 2. You can if you want to. No one's going to, if you do this and you write a power 2 here, no one's going to tell you anything. It's not wrong, but it's not the way it's usually written. Anyways, that means this gets canceled out, and x is now this. Well, now I need to have everything match a power 2 radical. Well, not a problem, because the 9 can be written as 3 times 3, which is 3 to the second power, and the m I can split it into, the 6 I can split into 3 2's. This, another one, and another one. And now everything can cancel out with that power 2 radical. Boom, 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 leaving me with just x is 3 times m times m times m, which is 3m to the third power. And that is number 17. So pause this if you need to. Let me know if you have any questions. We're going to move on to the last two problems, 18 and 19. All right, for 18, it's super similar. But now you have x to the third power equals to 27 w to the 9. Well, how do I get rid of this x to the third power? What is the opposite to an exponent to the third power? That's right, a radical to the third power. And whatever I do to one side, I got to do to the other side as well. Which means on the left side, it's gone, and I just have x, exactly what I'm looking for. And on the right side, I just need to deal with this now. Now remember that 27 is 3 times 9, and that is 3 times 3. So that is 3 times 3 times 3, right? I have 3 3's, which means I can just simply rewrite that as 3 to the third power. And the w to the 9, that 9 I can split it between 3 3's, right? It could be w to the 3 times w to the 3 times w to the 3. Because added up, they add up to 9. Now this allows me to just cancel everything out here. So x is simply 3 times w times w times w. So that is 3w to the third power. And that is the answer to number 18. So number 19, I have x to the second power equals to 16, y to the 4, and m to the 8. All right. I need to get rid of this power 2 radical. What's the opposite of a power 2 radical? A simple radical, right? A power 2 radical. I'm sorry, to get rid of the exponent to the power 2, I just use a simple radical, and I do to both sides. Well, on the left side, they're gone, leaving me with just x. Now, on the right side, the 16, I can write that as 4 times 4, which is 2 times 2 and 2 times 2, and that gets me 4 2's. So I can simply rewrite that as 2 to the fourth power, right? 4 2's. The y, I'm going to split it into 2 2's, and the m, I'm going to split that into a 2, a 2, oh gosh, a 2, and another one. Yeah, these get a little bit long. So 2 plus 2 plus 2 is 8, which is perfect. And because a simple radical is a power 2 radical, now, ooh, I made a mistake. I don't need to split it that far. I'm going to go back down here. Why am I doing that? See, yeah, that's good enough. I just need 4 times 4, which is 4 to the second power. So over here, I don't need a 2 to the fourth power. I need a 4 to the second power. They're the same thing, but what do you need in this situation? I need a 4 to the second power. I need a power 2 exponent. I don't need a 2 to the fourth power, which is a fourth power exponent. Now I can cancel everything out. See, I was going to go a little too far myself. There we go. And now x is simply 4 times y times y times m times m times m times m. So x is simply 4, y to the second times m to the fourth power. There we go, and that is numbers 19 and 18. Let me zoom that out a little bit so you can see everything. There we go, 18 and 19. Let me know if you have any questions. Pause this if you need to. And yeah, thank you very much.